All right, so we got a right cylindrical tank. I've drawn that out here. Always good to draw pictures with these, of course. The tank has a radius of 20 centimeters, so I know that this is going to be 20 up here. In case you're wondering, what does right cylindrical tank mean? It just means it's going straight up. It means that it's intersecting its base at right angles. How fast is the height of the water in the tank? Okay, so we got some water in here, and we got some height in it. So I'm going to go ahead and call that H. How fast does the height of the water in the tank drop? So we want to figure out what is dH over dt. That's going to be what our answer is. When the water is being drained at 25 cubic centimeters per second. So it's out at 25. And I'm going to go ahead and include the units. It helps me keep straight what is what. And so for the 20, I'm going to write the centimeters there as well. All right. Now, since the water is going out at 25 cubic centimeters per second, cubic centimeters tells me about volume. So this is throwing me back to telling me I got to use volume somehow. So we're going to go with the volume formula for a cylinder. So volume equals pi r squared h. So it's basically area of the base times the height. Okay. Let's go ahead and just figure out then the derivative with respect to time, because we can see we got to end up there anyway. So let's try that, see what we get. So that will give me dV over dt equals 2 pi r dr over dh, oops, not dh, dr dt h plus, oops, not 2 anymore, pi r squared dH over dt. What rule did I just use in order to be able to do that?
Product rule.
Yep, product rule, because we're really doing pi r squared times h here. And so I had to use product rule in order to be able to do that. All right, now let's go ahead and see if we can plug in all of the information except for the dH over dt that I'm looking for. If that's the case, then we know we're going to be in good shape and can solve it. If not, then we got to figure out what can we do instead. So, dV over dt. Yes, we do know that one. Now the water is flowing out at 25 cubic centimeters per second. But since it's flowing out at that rate, I'm going to make that a negative 25. So then, 2 pi times the radius. Do we know what the radius is?
20.
Yes, it's 20. Dr over dt. Do we know what that is?
Yeah.
Yes. What is it?
20.
It is 0. Yes, good. And it's 0 because the radius of this tank is not changing over time. So dr over dt is 0. And that's going to be times the height, which we don't know. But because I'm multiplying it by 0, I don't need to know what the current height is, because I can see already that this is going to make it negligible. All right, plus pi times r, 20, squared, dH over dt. Now I don't know what dH over dt is, but I don't need to, because of course that's what I'm looking for. That's what I'm trying to solve. So first thing is, that whole thing that's multiplied by 0, it's going to go away. So we know we end up with a negative 25 equals pi times 20 squared. Well, pi times 20 squared, let's go ahead and just call that 400 pi. dH over dt.
Now it's simple algebra to figure it out.
Yeah, now all we got to do is divide both sides by the 400 pi. And so that's going to give me negative 25 over 400. That reduces, of course. That would be 1/16. And the pi is also being divided there, so it's 1 over 16 pi. Notice it is still negative. That's what dH over dt equals. And so we end up with negative 1 over 16 pi. Yes, we can go ahead and calculate that. One last little detail. What are the units on this answer? Yep. Remember, it's h over t. H is measured in centimeters, t is measured in seconds, so it is centimeters per second. All right, now, in looking at doing this problem, the very first thing we have to do is really figure out how all these numbers are going to relate to each other and what represents what kind of a variable and all that stuff. So of course I would still go back to the idea of drawing a picture. Now if we're going to draw out this picture, this is what the information they've given us is really talking about. So you'll notice here, as the water increases and decreases, the height and the radius are both changing. And so notice I got some variable names in there. So R for the radius of the water, and H for the depth of the water. Now, we can always figure out what one of those is, though. Like if I know what the radius is, I can figure out H, or vice versa, because I know that the entire cone is 5 by 10. 5 radius, 10 height. That ratio will stay the same no matter where we are in this cone, as long as we're going perpendicular to that base. And of course, water, as long as the thing is upright, should be perpendicular to that. So the first thing we got to figure out with this one is, of course, the equation of calculate volume, because we're actually trying to figure out how the volume is changing. Notice up here it says it's flowing into it at 9 feet cubed per minute. So that tells me volume. So that's telling me that I got to be using volume with it all. So volume of a cone, do you remember it after the work you're doing like on that recent assignment?
1/3 pi r squared h over 3.
What?
1/3 pi r squared h, or some of you also remembered it, instead of the 1/3 you did the whole thing over 3. That's fine, same thing. But 1/3 pi r squared h. All right. So let's go ahead and start this one the same way. Let's go ahead and find our derivative with respect to t. So if I do that here, I'm going to end up with dv over dt equals, the 1/3 pi is still going to be hanging out there. And then, actually this is going to look a lot like the last one, right? Where we're going to have times 2r dr over dt h plus, because we're having to use product rule here, so pi r squared dh over dt. And then we can start plugging stuff in to see what all we can do with that. So we know it's flowing into it at a rate of 9 feet cubed per minute, so that we put the 9 in there. 1/3 pi, of course, stays at 1/3 pi times 2r. Do we know what the radius is at this time? Well, I don't at the moment. I might be able to figure it out, though. I'll come back to that. dr over dt. Do I know what dr over dt is? Well, that's how quickly the radius is changing. Well, I know I'm trying to find how fast the water level is rising, so that means I'm trying to find like dh over dt. Can we just use the ratio to figure out dr over dt? No, I'm afraid it doesn't work quite that way. So at the moment, I'm just going to leave that as dr over dt times h, when the water is 6 feet deep. So we can know that part, so we know h. Oops, let's actually plug it in. There we go. Plus 1/3 pi times the radius, which I don't know at the moment yet, dh over dt. All right, now, can I figure out the radius? Well, yeah, I can figure out the radius here, because you'll notice we're told that the water is 6 feet deep. Notice in the cone overall what the ratio is. 5 feet of radius gives us 10 feet of depth.
3.
Well, that's twice as much. The height is twice as much as the radius. So, of course, our radius here must be 3. Okay, so I can go ahead and plug that in. I got my 3 there, I got my 3 there. Cool. Can I solve this now?
Yes.
Can I figure out what dh over dt is?
Yes. No. You need dr over dt.
Yeah, we got a little problem there, right? We don't know dr over dt. And the tricky part with this one is there's not a way to find it. We can't assume that it's like half as much or anything like that. So we end up with a little bit of a problem here. We've done all of this work and we all of a sudden hit a roadblock. We cannot use this method. So,
You're going to have to pay for that, man.
we're going to go through another method here. And I'm going to show you another way you can approach it. So, we got to start over. And sometimes that happens when we're doing these math problems, is sometimes we go through it and we realize this method isn't working, I got to go and try something different. So, remember the problem that we just ran into was that I ended up with both dr over dt and dh over dt in my final equation. Now I do want dh over dt in my final equation because that's what I'm trying to find. But I don't want dr over dt in it. The only way that I'm not going to end up with dr over dt in my final equation is if I eliminate r from this equation. Well, remember earlier we were able to figure out what r equaled, right? We can actually use some of that information because I know that the 5 over 10 equals r over h. Notice I could write an equation here for r.
You could.
Multiply both sides by h, and you'd end up with 5h over 10 equals r. Or, I mean, let's go ahead and simplify this. Let's make our lives a little bit easier. H over 2 equals r. By doing that, we now can make our lives a whole lot easier. So, we're going to go over here, and I'm going to rewrite my equation with that substituted in. So it's now going to be 1/3 pi times h over 2 squared h.
Oh.
Notice we got rid of the r. So now when I go find the derivative here in a minute, it's going to be a lot easier. But in order to make that derivative even easier, I want to simplify this first. So I'm going to go ahead and square h over 2. Remember, that just means square the top, square the bottom. And so if I do that, I'll end up with 1/3 pi times h squared over 4 times h. All right. Well, got to make a bunch more room here. I can clean that up even more. V equals h cubed times pi. Yeah, that just doesn't look right to me. Let's call that pi h cubed. I always like to put the constant first. Not that it changes anything mathematically, it's just style. Over 12. This is now our volume equation. For this particular cone, where it has this particular ratio of radius to height, this is the volume of the cone. The nice part about this, though, is now I can go ahead and find my derivative. And so, dv over dt equals pi times 3h squared dh over dt all over 12. Now some of you might be a little bit thrown off by the over 12. I don't have to use quotient rule here because it's over a constant. It's not over a function. If that's throwing you off, remember I could rewrite this equation up here like this. Pi over 12 times h cubed. That means the same thing. Notice it's just a constant times h cubed. It's just a different way of writing it. If you want to do it from this form instead, by all means, feel free to do so. And so, I'm going to go ahead and clean this up before I go ahead and do too much math on it. So dv over dt equals pi h squared dh over dt over 4. Now that we know that, go ahead and plug in the values that we know. And you should find that we know values for everything except for the dh over dt. And so when we plug in, this is what you should be looking at. From here, it's just a matter of solving it through. So multiply both sides by 4, divide both sides by 36 pi, and you should end up with 1 over pi. Notice the 36's happen to cancel each other out. Awfully convenient, right? So dh over dt equals 1 over pi, but again, we want to include the units here. So that's going to be 1 over pi. Again, you could get it as decimal, that'd be fine. Our units are what here? What is h measured in? Feet. Per, what's t measured in?
Time. Whatever.
T is measured in minutes here. It's easy to assume seconds, but this one was measured in minutes. The original problem told us that. So this then is our final answer. Now, first thing you want to do is you want to make a drawing. So I'm just making a basic drawing here of my cone from the side. I'm not trying to get too fancy here. And I'm going to start labeling stuff. Now, when I start labeling it, I didn't have a nice way to label what the volume was. So I just went ahead and wrote down that dV over dt equals 5 cubic meters per second down here. Now, you notice h I use for height. And we're told that the radius is twice its height. So the radius then I labeled as 2h. Looks like my picture is not drawn to scale. Oh well, doesn't matter. It matters only that you actually get it set up right. You got the right numbers in the right places as far as your picture goes. All right, now we set up our volume formula, and then we go ahead and we plug in our radius. Remember, radius is twice height, so I plug in 2h for my radius, and then simplify that to get a simpler volume formula. And again, I just want it in terms of h because it's asking for what dH over dt is. And it doesn't tell me what dr over dt is, so I need to be able to do it that way. And so first thing you got to do then, once you have your formula for volume, find your derivative with respect to time. Right, and then when we work that through, we should be getting an answer of 1 over 80 pi, if we're going to represent it exactly, meters per second.